Today we will be discussing reflections. The definition of a reflection is a transformation in which the figure is a mirror image of the original figure. It can also be called a flip. The figure you are reflecting will not change in size. The four types of reflections we are discussing today are a reflection across the x-axis, a reflection across the y-axis, a reflection across the origin, and a reflection across the line y equals x.
Now this is a story all about how our reflections got flipped, turned upside down, and we'd like to take a minute, just listen now. We'll tell you how we reflected and what went down. In mathematics class, born and raised, at my desk is where I spent most of my days, plotting points, graphing, and switching sides too, and reflecting some graphs inside the school when a couple of problems that are kind of hard started giving me trouble, so I made a flashcard. Got one problem wrong, my teacher got scared and said, "You're missing the signs on your ordered pair." I checked my graph, and when I found a mistake, I changed the sign, and it was time for a break. If anything, I could say reflections on my face, so I thought, now I can solve it.
In our first example, we are reflecting across the x-axis. In order to do this, we are changing the sign of y. So in our given graph, we are going to plot each of the coordinate points in our table. So for the first point, we have -3, 2. In our second point, we have -2, -2. In our third point, we have 2, -2. In our fourth point, we have 3, 2. And in our last point, we have 0, 4. So we don't get confused, we're going to make our new table first before we start graphing the reflection. So we're changing the sign of y. So our x values are staying the same. And now we're changing the sign of y. Now we're going to plot our new points in order, and then we're going to connect the points to get our reflected graph across the x-axis. So first point is -3, 2. So -3, -2, I'm sorry. And now we have reflected our first given shape across the x-axis, and this is what we conclude with.
In our second example, we are going to reflect across the y-axis. In order to do this, we are going to change the sign of our x-coordinates. So, in our given example, we are going to take the points of our line, and then we will put them into our xy table. So for our first point, we have -4, up 4. Our second point is -5, up 1. Our third point is -1, up 2. Our fourth point is -2, down 2. And our final point is over 3, up 1. Now, like I said before, in order to reflect across the y-axis, we are going to change the sign of x. So first, we will complete our table in order to make graphing easier. So now, we will graph this. So we will start with our first point, which will be 4, 4, over 4, and up 4. And now you can see that this is a reflection across the y-axis.
Okay, for our third example, we're going to reflect across the origin, which means we're going to change the sign of x and y. So the first thing we're going to do is we're going to write the coordinates. So first we have -1, 0. Second we have 2, -2. Third, we have 3, 0. And fourth, we have 1, 3. So the next thing we're going to do is we're going to change the signs of both x and y. So now we're going to plot these points. First point we have is 1, 0. Points. And here we have a reflection across the origin.
For our fourth example, we are reflecting across the line y equals x. In order to do this, we are going to switch the x and y coordinates. First, we are going to plot our coordinates on our table. We have -5, 4, -3, 2, 1, 5, and 3, 5. Now to reflect across the line y equals x, we are going to flip-flop our x and y coordinates. Plotting these points, we get 4, -5, this is a reflection across the line y equals x.
I grabbed my next problem and knew it was good, and I yelled to my teacher that I understood. Looked at my graphs and they were finally right. Reflecting across every